We have been talking about integration of two different systems, machine-type communications and wireless access systems. These two systems actually has totally different requirements. One is very low delay, low energy, machine-type communications, and wireless access systems. Today's 4G is designed for very high data rates, right? It's like Ferrari versus a pickup truck, as one speaker made this analogy. So. How do you think this will be possible to integrate those different requirements in one system and call it 5G? Do we really need to do this?
It's a very interesting question because I think the industry at the moment is really looking quite hard at, do we need two physical air interfaces or multiple physical air interfaces? At what frequencies will they work at? There are very, very different demands on machine to machine for coverage requirements, for instance, that are going to be very different from very high dense high-speed networks where people are going to want their ultra-high definition video being streamed. So I think at the moment we don't know the answer. There are technologies being looked at, for instance OFDM-based systems where you use one or two sub-carriers as the main channels for the machine-to-machine communications, the very narrow band, and therefore you get longer distance. But we really don't know at this stage. It's something that we're looking into.
When we look at the architecture of today's networks, wireless access network architecture, what do you think we need to change in this architecture to enable billions of devices to communicate within this architecture?
Probably very little. The architecture itself can handle masses of devices anyway. I think one of the questions is, can it do it economically? And what we're really going to have to focus on is both the economics and the technology at the same time, because these devices will only generate small amounts of traffic, which in turn will probably mean that they'll only generate small amounts of money for the operators. So we have to make sure that that traffic is handled in an efficient, low-cost manner. Otherwise, the systems won't be economic, and you won't get the billions of devices that we're talking about.
So if you think that's only economic, then why do we need to design a new system called 5G? I mean, we can already achieve this with extending 4G, right?
Well, again, it's a good question. We think that there are certain requirements that you can't meet in today's system. So if you look at the very, very high data rates and very dense urban environments, then there are problems out there to be sorted that are difficult and expensive to sort today. So we talk about LTE and carrier aggregation for a terminal manufacturer like Samsung. Carrier aggregation is a great technology, but it is difficult and expensive to implement in the devices, and we can only go to 2, possibly 3 carriers together because we have RF change, which cost money. And so what we're looking at is improving the 5G networks over and above what we've got today to provide some of these new services in a cost-effective manner.
Okay, thank you.